Okay, good afternoon all. I hope like all the three sessions that went were good. Did you like it? Like this is a community part where we care and share about each other. So it's not like us only we are talking. We need you people also to come and speak. Okay. So about me, I am Abhishek Nandy. I am also co-founder of Dynopii, and currently I'm also working with Udacity as moderator for their nano degree program on MLOps. Okay. And apart from that, I do a lot of work for Intel as well as Microsoft. Uh, Being there, I contribute as a Intel Black Belt developer. I have contributed to their one API source main GitHub repository too. So today's session would be like, how many of you are interested in machine learning? Probably yes, many of you are there. But the most important part in machine learning that lacks, or what doesn't, what is not being told to you is like out of 100 projects, 85 projects don't see the limelight. Do you know why? In production, any guesses? No idea? Nothing? So the most important, when you are adding in a data into a system, after a period of time, it degrades. So you need to continuously upgrade the system. Okay. So if you are feeding in the data, the most problematic area is the model serving part. Okay. So generally, I'm just showing one just small scenario over here. Like if you have trained a model, the general tendency is like say it needs to go up, it needs to learn, but over the period of time, it drifts. So model drift generally happens when the data, there are problems in data. So how do you identify that? That's the big problem. So here comes the scenario of applying parallel computing. Okay. So parallel computing is nothing but how to manage the workloads that are being offloaded for model survey. Okay. So there are different devices. I think so. You might have one GPU in your home. Okay. How many of you have NVIDIA GPUs? So, so NVIDIA GPUs are like it's there in market, but might be some people are also using AMD. So I need to know how many of you are using AMD device like graphics. So a program that is being run meant to run for CUDA will definitely not run in AMD. Okay. So SYCL comes in the picture. Okay. So what does SYCL do? It is nothing but C++. Okay. It's on top of C++, it is being built. Now you might be asking like why everybody is putting stress on that? Like how Rishabh told like there are things like where you write once and deploy to everywhere, isn't it? So that is meant by the fastness of the language. Okay. So the fastness of the language. So if somebody asks you, somebody is teaching you Kotlin, or say in the matter of fact Java also, the main Kotlin's backend where it is being built, it's built on C++. Okay. So if you know C++ top to bottom, you can solve a lot of problems. So SYCL is built on top in using C++ 17 standards, and now you have different ways to identify. Now, the people who are using CUDA, they use something called CUDA SYCL. Okay. Okay. Why it is important? Because when you are trying to access a particular library, you have to include a namespace. Using namespace, SYCL itself. Now you can access accordingly the components or the objects of that. Okay. Here also there is an important part that is known as lambda. What are lambdas used for? Any idea? General term, like I guess many of you are learning any computer language. So any idea how what does lambda do?
It's kind of higher order functions.
Higher order function, yes. Okay. Apart from that, expressions, yeah. So why these expressions are useful?
Less parameter.
Less parameters, yes. So you can yes. So in that case, what happens is like when you are using a lambda expression, it becomes easier for you to just hierarchy. So you are trying to access certain things with that, it becomes easier. So lambda expression is very much important in this particular SYCL. Okay. So one of the important part when you start SYCL is parallel underscore for loop. Okay. I'll just show a demo for that. Okay. So what it does is that it declares certain parameters and it allows you to access a particular object that is created in SYCL itself. So let me just show you how a SYCL program works. Okay. What are the problems you face? You have a CPU. Okay. You have a CPU. Now, somebody might have a GPU that is meant for CUDA, like NVIDIA GPU itself. What are the things you think would be problematic when you are programming over here? I will break down SYCL according to that. I want to interact with you so that you understand this language. Any idea? Okay. So the first thing is that an object that is being created in CUDA cannot be directly accessed with the same way in the CPU itself, isn't it? But if you are offloading or like coding in CPU, that can be accessed by CUDA. Okay. So the first thing you need to do is you have to declare what you call is a queue. Okay. This queue, what it does is that if you have the objects that are being created, it goes directly to this place. Okay. Now the operations that are being done are done through lambdas. There you have parallel underscore for loop and other things that are there. So you can use it. Okay. Now you might be asking like why we are doing this. But accordingly, in computer, you can divide the code into host code and also into a device code. To devices. So if you just query your system or you go to the system information and query it, you will see like what are the devices present. Might be you have FPGAs, you have graphics card, GPU itself, but these are all different. Okay. So you cannot directly access them. So you have to segregate according. So the queue helps you to for this distribution. Okay. Now the most important part is like any machine learning application that is running. Okay. It takes up resources, isn't it? It takes up resources. We have around 16 gigs of RAM in our system, but some of the workloads that are being offloaded might need 6 GB or might be more than that. So what needs to be done? Any idea? I have started a process where there is a machine learning algorithm is running continuously. So it runs forever. Okay, it runs forever. If it is a system deployed in production, it needs to run forever. But there might be condition like you need to stop it. So what needs to be done? General concept. For Silverskas and Galvin. Okay, right about it. So anything that needs to be what is a process and what is a thread. Okay, thread. Okay. So when you are using this particular process or like there is a machine learning application working on, you are always to run this application.
some programs that needs to wait.
Isn't? But
After that, you need to also release the allocation of memory. So the final part is like
freeing the. So again, you have
the queue.
process. So this is the complete flow of how a SYCL program runs. Okay. So there are industry standards. If you just move, I will just move to the next slide. So as I mentioned, like when you are targeting GPU, some of them would be using the standard templates for parallelism. Okay. C++. Then we have OpenMP. Any one of you have heard about it? OpenMP. Okay, let's just you have HIP. What is this HIP meant for? This is meant for AMD devices. Okay, HIP SYCL is meant for AMD devices. Now these are different layers and different projects that are running. This Raja particular
for graphics for
Intel graphics, and above that you have SYCL level part. Okay. So what is SYCL? As I mentioned, it targets C++ programmers. No
about it.
High paid. So there is a need of ML engineers who takes care of the that are in production, because production matters the most. So you have to know about it, and it's a very high paid job. Okay. So no language extension, no pragmas, no attributes. Borrow lot concept from battle tested OpenCL. OpenCL was a standard that is meant for different kind of activities in parallel programming that has been extended to C++. See, it has been mentioned that it uses template and lambda. So SYCL is a specification developed by the Kronos group.
OpenCL, Vulkan, and OpenCL. Okay. So
That's the much more. Now this is the SYCL roadmap. Okay. So the SYCL roadmap is meant for different kind of architectures. Intel is there. You have this X Linux which uses the tricycle. HipSYCL is for AMD, and there is one for NVIDIA GPU also. It's not shown, but it's there. So if you need this roadmap, I can share it to you. Okay. So I'm not getting into DP C++ because I have already shared it in the previous section. But you might, these are the things used, but how to see it visually, isn't it? So after running a SYCL program, you can dump their code and you can visualize the task graphs that are there. So when the task graphs are opened, there is this kind of visualizer. Okay. So this is available online itself. Now, if you want to modify it accordingly, so how do you? So if I say like, I'm just modifying a cluster graph. One important part of this graph is it is DA. That means directed acyclic graph. It cannot go back. It is moving in one direction itself. Okay. So let us just modify certain things, like if you want to add a different cluster over here, you can do that. Just copy one of the cluster that is there, and it's in web, completely free. You can just check and you can also modify and work accordingly. So if you want to modify or like change different patterns, you can directly change it to using this the cyclic graph that is there. Okay. So if you want to add a node between say A
2B2 is not there, I guess.
okay. So I will just use. So in the picture itself, it gets modified A2 to B2 as I've changed it. So any kind of process and sub-process on, you can create clusters and check. Or when you have an entire C++, there is a dump method that is there. You just dump format, DOT format, and then you can see it according. This level, but I am teaching because it's very much needed in industry right now. We need people for model retraining or deployment. It's not only like machine learning who are developing the models that are required. It is we require people also who can maintain the code. For this, we need backend support. Okay. If you have access to Jupyter Node, you will be able to see this kind of thing. But the most important part is this Q subfile, where again I will just emphasize on this nodes. Q GPU PPN. In the Qs in the Intel Dev Cloud, you can change the GPUs. You can also change it to a higher order GPU. If I just go back to the file option, yeah. So if you just check, one of the most important part is like in February 1st, 21, they have added this Iris 6 Max GPU. That's also available as a node. You can run your application directly and you can check for the outputs directly on GPU itself. So when you just register to DevCloud, these are the offerings that are there. You have one API based toolkit. Rendering is meant for graphic people, like if somebody is interested in graphics, they would use this rendering toolkit. We have HPC high performance computing toolkit, OpenCL compiler, Quartus Prime, AI analytics toolkit. Somebody who is into Python and all, they will use this. And this is the Syn compiler. So this is one of the applications that I've made, and also it's being selected for the Dev Conference Asia Pacific. It uses the clusters of different kind of what you can say the DNA or the RNA standard we have. Okay. So the first part is it calls in the NumPy and also the cluster programming library, and we use it accordingly. First of all, we have to enable this Jupyter Notebook. But you might be asking, like, how do I use Intel over here? You have to first use scikit-learn, and then you have to change it according to the Intel's offer. Okay, so in the meantime, as the okay, so if you see right now, it says the Intel extension for the scikit-learn is enabled. Okay, so it's there right now. What I am doing in the next step is I am using a data set that contains RNA of cats and dogs. Okay, so the most important part is over here. Now, particular library that you see, you can on the go change the ordering of this. So if I click the sum, so the next structuring automatically changes. Now, if you want to find what is the most important thing over here, you can do is like for cancer. So you can directly change the order and recluster it all of the RNA pattern that is there. So these the third thing over here are the heat maps. So you might be
do.
I will just get into this, and if I just go deep, you can directly see what is the problem or why it is being showing red, like what analysis for that. You can also use cancer data to check for the anomalies that are there in the structuring itself. If you just click on it, it's not working. It gives the entire like the standard of the protein that is there. You can see, and this data set is huge. So for like big data sets, you can directly apply cluster programming and you can check and update accordingly. So this might be the end because I don't want to waste time. There are also pizza waiting for you. You had been studying for a long time. But the only idea over here why you people come or why we meet is we need you people also to come and speak. Also with your new projects so that we can learn and also we can share. Okay. So any questions till now? Any questions? Any questions regarding why parallel program is important? Would you like to learn more on this? So why I am telling this is because if you want to be a CUDA programmer or like if you want to move into machine learning parts that helps in developing, not in developing, but deploying the machine learning models to production. These are very high paid jobs. So if you are learning this, you will get very good salaries. Okay. So how to generally what you can do is like for this you have to have knowledge on machine learning itself because if you are not able to make a model on your own like regression model, you have a data, you have a then only you can apply it to production. So if you want to test the data accordingly, you need an approach. So accordingly, you have to study. There are resources in YouTube. Go to Google or itself. You can learn from. And I'm not showing it. There are libraries that are there. You can learn from. Like Evidently is a very good library for finding out the discrepancies in the model in production. Okay. So these are the things that you can go and learn. And if you want more details on C++ and also in SYCL itself, you can get in touch with me. I am there to help. Okay. So I would ask you people to have lunch if you have. And also ask Anubhav